A review on the use of high-density polyethylene (HDPE) in concrete mixture. Abstract: the rapid industrialization and urbanization in our country has resulted in significant rise in the quantity of plastic waste. Most of polymer wastes is abandoned and not recycled. It leads to serious problems of wastage of natural resources and environmental pollution. Synthetic fibers, plastics, and rubber belong to petrochemical compounds and are not easily biodegradable. This problem can be reduced by using plastic waste in the production of concrete. It helps in reducing concrete cost, landfill cost, energy saving and protection of environment from pollution. Concrete with replacement of certain percentages of polyethylene material is prepared after mix design. Various tests on cement like specific gravity, fineness modulus, strength tests, setting time, etc. are performed. Mix design using IS code method is done and cubes, beams and cylinders are cast with and without plastics and tests on concrete like slump test. The mechanical properties of concrete like compressive strength, split tensile and flexure test are conducted and compared with the result of standard specimen. As for cost analysis, the results showed that polymer concrete is more cost-effective than conventional concrete. As part of case study, a multi-storied building is taken and data is collected, building frame model is developed and is analyzed. Keywords: lightweight concrete, polymer waste, mechanical properties, HDPE. Introduction: lightweight concrete can be defined as a type of concrete which includes an expanding agent in that it increases the volume of the mixture while giving additional qualities such as lessened dead weight. The term lightweight concrete itself describes a wide range of special aggregate bases. The specific gravities and in terms of density of compactness of these aggregates are significantly lower than that of normal weight concrete aggregates. Lightweight concrete can be used for as lighter weight thermal insulate and non-structural as well as structural concrete composed of extremely light natural or man-made aggregate. Multi-storied buildings are indispensable in urban areas due to high cost of land, shortage of open space and scarcity of lands. Many times, these multi-story buildings are built with regular concrete, steel, and other materials where the loads are high and require heavy structures and cost may not be effective. The use of lightweight concrete and lightweight materials will reduce the dead load of a structure, which then allows the structural designer to reduce the size of the columns, footings, and other load-bearing elements. Structural lightweight concrete mixtures can be designed to achieve similar strengths as normal weight concrete. Fine aggregate used in concrete is replaced partially by plastic wastes in known percentages and properties are tested. The optimum percentage at which higher strength is obtained is calculated. Advantages of using waste or recycled plastics are: it will help on reducing the municipal solid wastes being landfilled and it became an alternative to pressure-treated lumber that leaches toxic chemical into water. There are many types of waste and recycled plastic that has been used in concrete mix. In this paper, an attempt has been made to study HDPE plastic, high-density polyethylene. HDPE has stronger material properties, harder, opaque and more resistant to high temperatures. HDPE is commonly used for colored milk bottles, oil container, shampoo bottles, and much more. HDPE is one of the safe plastic materials because of the ability to prevent chemical reactions between HDPE plastic packaging and the packaged food or beverages. HDPE is the polyethylene grade with the highest rigidity and the least amount of flexibility. It is well suited for a wide range of applications, like trash canisters, and a multitude of everyday household goods, such as small bottles and clothespins. This lightweight, non-toxic material is easily recyclable and serves increasingly as an alternative for less environmentally friendly substances. Ragatate Atul M1, he has done research on use of plastic in a concrete to improve its properties. Plastic bags which are commonly used for packing, carrying vegetables, meat etc. creates a serious environmental problem. Plastic bag last in environment up to 1000 years. Because of plastic bag lasts so long, the number of plastic bag accumulated increases each year. Disposal of large quantity of plastic bag may cause pollution of land, water bodies, and air. The proposed concrete, which is made up by adding plastic in concrete, may help to reuse the plastic bag as one of the constituents material of concrete, to improve the certain properties of concrete. The properties of concrete containing varying percentages of plastic were tested for compressive strength and split tensile strength, and shows that an appreciable improvement in tensile strength of concrete can be achieved by introducing cut pieces of plastic bags. H. Baumard et al. To lightweight concrete structures, potentialities, limits, and realities. This paper was published as part of the proceedings of the CIAD Congress on Lightweight Concrete, London, the International Journal of Lightweight Concrete, Volume 2, Number, December 4, 1980, by concluded that structural lightweight concrete can be economical, especially in the combination of high load-bearing capacity and low density, but also by the low density alone. Kamsi Ahmad, Ismail et al. 3 Study of lightweight concrete behavior. This research work thesis is carried, 2004, and the initial findings have shown that the lightweight concrete has a desirable strength to be an alternative construction material for the industrialized building system. The foamed lightweight concrete is not suitable to be used as non-load bearing wall, as the compressive strength is 27% less than recommended. Nevertheless, the compressive strength is accepted to be produced as non-load bearing structure. Jan A. Overly et al. 4 Increasing ductility in heavily reinforced LWAC structures in Engineering Structures, Volume 62-63, Jensen founded that the ductility index proved to be the same for beams with fiber or stirrups, and was almost doubled for beams with both fiber and stirrups, and the effect of adding steel fiber reinforcement in the compressive gradient zone of full-scale, over-reinforced LWAC beams was much more pronounced regarding ductility than the effect achieved from tests of stress, strain relationships on cylinders with the same fiber reinforced LWAC. Case Study 5. The experimental setup has been done to analyze the effects of structural lightweight concrete seismic behavior in high-rise building by framing out simulation model in STD.Pro software tool. The building is having 15 stories and overall 44.8 m assembled as G+14. The building to be analyzed here is completely made up of lightweight concrete. Structural members includes both horizontal and vertical members. Structural details of LWC, G+15, building. Analysis of building. Analysis is done by using STD.Pro under design consideration IS 456-2000 and IS 13920-1993. Applying the response spectrum command loading for dynamic analysis. This capability allows for analyzing the structure for seismic loading. For any supplied response spectrum, either acceleration versus period or displacement versus period, joint displacements, member forces, and support reactions may be calculated. Modal responses are combined using the complete quadratic combination, CQC, methods to obtain the resultant responses. Result analysis. A lightweight concrete structure is analyzed on the basis of codal provisions and in STAAD.Pro software with different specifications of design details as specified previously. The result analysis is obtained by the software as per the feeded data. Table 1 Comparison of shear forces. Table 2 Max beam stresses under applied loads for M35 grade concrete with Fe 415. Results as obtained from tabulated data and graphical which make structure to deform or get displaced from representations shows that there is considerable fall down connecting joints, or say, the node-to-node displacements. In shearing forces and moments along all coordinate axes, data shows that the structural entity assembled is at most under applied structural defined loads like, dead, live and on critical side as if not properly investigated for seismic loadings. The loads causes significant vibrations. Time period and its after effects, bursting of column and beams in lateral direction, which might be disastrous. The confined detailed go-through in this research work study reveals that the lightweight concrete reduces effect of seismic vibrations and reduces threat of structural collapse under base shear, story drift and soft story effect. Lower density material reduces seismic vibration effect by allowing forces to pass through structural members. Amount of reinforcement required in lightweight concrete structure is lesser than normal weight concrete as the value of moments get reduced. Danger of story drift under seismic response is reduced by increasing stiffness of members. Ductility of structure is also increased by using lightweight concrete due to reduction in dense medium, which retards and dumps the seismic vibrations within it. Conclusions. On comparison between normal weight and lightweight RCC building under similar load cases, it has been observed that shearing, tearing and moments are considerably reduced in lightweight concrete structure. Lightweight concrete structures in a seismic condition save considerably on cost of the entire project. The percentage of reinforcement required is also reduced for lightweight concrete members as moment acting on the member gets reduced. The dynamic analysis results so obtained shows that structure undergoes high lateral deformation and deflection but remains safe even under critical values of forces.